Hi there, this is the last lesson in the momentum series in terms of content. So momentum concepts, this is explosions, shouldn't take too long. It's a pretty simple, straightforward concept. You can get asked some pretty difficult exam questions though. So in an explosion, kinetic energy is increased and both the total energy and total momentum are conserved. So what I'm going to do is show you a question, show you how to answer it. So here's an example. So a gun of mass 3 kilograms fires a bullet of mass 15 grams. If the bullet moves off at a speed of 250 meters per second, calculate the recoil speed of the gun. So this is pretty easy. So all you've got to do is the momentum of the gun is equal to the momentum of the bullet. Now one of these should be negative because they travel in opposite directions. It's not always important. It depends if the question wants a direction. You could either state it, maybe you could put a minus. It depends. So in this one, the momentum of the gun is simply the mass of the gun, which is 3 kilos, multiplied by the velocity that it will recoil at, which we just call V, equals the mass of the bullet, which is 15 grams, so 15 times 10 to the minus 3, multiplied by its velocity of 250 meters per second. So the velocity of the recoil is the 15 times 10 to the minus 3 times 250. Just tidy that up. Divided by 3. So that gives a velocity of 1.25 meters per second. Let's move on then to another one. So a very similar question. If you want to have a go at this one, after doing the example, just pause it and have a go. So a bullet of mass 8 grams is fired with a velocity of 120 meters per second from a stationary rifle of mass 3.5 kilograms. Consider the rifle and bullet to be an isolated system. What are the recoil velocity of the rifle and the total momentum of the rifle and bullet just after firing? Well, the total momentum of the rifle and bullet is 0, because whatever momentum it had in one direction, you would have an equal amount of momentum in the opposite direction. One's positive, one's negative, they cancel out. So let's have a look at this one then. So we've got the gun and the bullet again, or rifle. So momentum of the rifle is equal to the momentum of the bullet. And again, you could have one of these as negative. It's not really necessary in this way. In an exam question, if it showed the gun firing to the right and gave you positive values, then you may wish to give, your answer. If you're figuring out the other way, you may wish to call that negative. But it depends. In this instance, I'm just going to leave them both as positive. So we've got the momentum of the rifle. So we've got the mass of the rifle, which is 3.5, times its velocity V, equals mass of the bullet, which is 8 grams, 8 times 10 to the minus 3, multiplied by the velocity of the bullet, 120 meters per second. That's just straightforward like last time. So 8 times 10 to the minus 3 times 120 divided by 3.5. And that gives a velocity of 0.27 meters per second. It's very straightforward with numbers. That should be okay. Let's have a look at the next one. Sometimes you can get these types of questions where it looks like this. Now this is very challenging, very challenging. If you want to have a go at this, please do. It may take you a while. I will show you how to go through this. So good luck with this one. For a question like this, first of all, I'm going to look at the momentum, then the total kinetic energy. So let's have a look. So the recoiling nucleus has got momentum NV. NV equals, and the half particle has got momentum m little v. I'm gonna actually call that u, just so it's easier to see. So let's call that u. And what I'm going to do is find v. So v will be equal to mu over n. And you probably need to write this down and just leave it off to the side somewhere. Then if you apply the kinetic energy, so the total kinetic energy will be the kinetic energy of the recoiling nucleus plus the kinetic energy of the alpha particle, you may be able to do a substitution and figure that out now. Let's carry on. So I'm going to remove this. So the total energy, total kinetic energy, is equal to the kinetic energy of the recoiling nucleus, half mv squared, plus the kinetic energy of the alpha particle, so half mu squared. Then what I'm going to do is substitute in for v the expression v equals mu over n. So the total energy is equal to, so we've got n, and then the v squared. So that would be m squared u squared over 2n squared plus a half mu squared. So on this side, this n cancels. So we're left with m squared u squared over 2n. What you've got to notice is that, well, that's a half. So we've got a half m u squared on this left-hand side. We've just got the m extra to give the m squared and the n on the bottom. So that is actually equal to this half and then mu squared is actually equal to the kinetic energy of the alpha particle, the same expression as what's on the right-hand side. Let's just get rid of that. So what we can write is this: the total energy is equal to m over n. And then we've got the kinetic energy of the alpha particle plus the kinetic energy of the alpha particle. Then we just need to solve for E alpha. So if you got to this point, or if you want to try it from here, please do. I'm going to clear the screen and then carry on. So m over n, E alpha plus E alpha. So what we're going to do is multiply everything by n. So when total energy times n equals m E alpha plus E alpha n. Then we can just factorise on the right hand side. So we get total energy times n is equal to, pull the kinetic energy of the alpha out, bracket m plus n. Then we just need to rearrange for E alpha. So E alpha is equal to n divided by m plus n multiplied by the total energy. We can put brackets around this one. And that gives us the expression that's required to solve this question. Hopefully that went okay. If you struggle with that one, maybe try it again, see if you can get the answer. And that's momentum finished. Thanks for watching, I'll speak to you soon.